This is a warm-up and review of radicals and simplifying them, which we call rationalizing them, to get any sort of square root out of the denominator. And it's also a little review on working with complex fractions. So the first thing we're going to look at is this problem that's 1 over the square root of 2. And we can't leave it like that. We can't leave a square root in the denominator of a function. It's not the proper way to simplify that. So if you recall, all you have to do is multiply the top and the bottom by the square root of 2. It's really like multiplying by 1, so we're not modifying the problem at all. And in the numerator, we're going to get radical 2. And in the denominator, what we actually have is square root of 2 times the square root of 2, which is the square root of 4. But that really is 2 when we re-simplify it. So here's our final answer. So square root of 2 times the square root of 2 is like the square root of 4, and then simplified. Or you can also think of it as a square root of 2 squared. But it ends up going to the point where we have no radical in the denominator anymore. So let's look at the next problem. This has 4/3 divided by 7/5. And with complex fractions, what's really happening is you have 4/3 being divided by 7/5. And you have to remember, when you are dividing by a fraction, you have to flip and get the reciprocal of the divisor here, the second fraction. So we really have 4/3 times 5/7. And that, when we simplify, is going to be 20 over 21. And there's our final answer. So the main thing to do here is to flip the second fraction. And that's like taking the reciprocal, flip the second fraction, and you multiply to get the answer. All right, let's look at problem C. And for problem C, we have the same exact thing. So we have 2/3, and I'm going to flip as well. So instead of square root of 2 over 5, we're going to have 5 over the square root of 2. And when I go ahead and multiply that out, remember you multiply the numerators, so 10, multiply, and we have 3 radical 2. And we don't combine these because the 3 is not in a radical. If it was in a square root as well, we would multiply that. So this is where we run into a problem because we have a square root in the denominator. So if I take the numerator and the denominator and multiply them by the square root of 2, and I go ahead and keep simplifying, I have this 3 on the outside, and I have square root of 2 times the square root of 2, which is our square root of 4, but that ends up just being 2. Let me simplify that, and we'll have to simplify it one more because I can reduce 10/6, and I can reduce each of those by 2. So I have 5 square root of 2 over 3. You can accomplish these in a lot less steps, but this is probably the best way to see it going step by step. In this last problem, problem D, we have a complex fraction. We just really have this 3 radical 3 over 1. So if I go ahead to simplify it, square root of 2 over 5 times 1 over 3 square root of 3. Now, a lot of times people go to cancel or do some, cross multiplication, but the only time we can cross multiply is when we have a proportion or an equal sign here. But this is multiplication. So we're going to multiply square root of 2 times 1, and here we have 15 times the square root of 3. And again, this is not simplified because we have a square root in the denominator. So let me multiply the top and the bottom by the square root of 3. Now in the numerator, I have the square root of 6. They're both under square root, so I can multiply them. And then in the bottom, I have 15 times, well, square root of 3 times the square root of 3 is just 3. So my final answer is the square root of 6 over 45.